Factorising harder quadratics. We're going to start by multiplying this number by this number, so the number in front of x squared, i.e. the coefficient of x squared, by the number at the end of the quadratic. So 2 multiplied by 5 gives us 10. We now need to find two numbers which multiply together to make 10 and which add together to make us this number here, 7. There will only ever be one possible combination, and in this example the combination is 2 and 5. We can now use the 2 and the 5 to split up the middle term. So we have 2x squared at the start plus 5 at the end, but instead of the 7x we have plus 2x plus 5x, and those terms could have been written in either order. We're now going to draw a grid in which we fill in 2x squared here and then positive 5 over here. The other two terms can go in either of the other spaces. This is a multiplication grid. So we look down this first column here and we try and find a common factor of 2x squared and 2x. The obvious choice is 2x. Now, how do we multiply 2x to get 2x squared? We multiply 2x by an x, so we fill in an x there. Now look at this space over here. What do we multiply 2x by to create 2x? A positive 1. And then finally up here, what do we multiply 1 by to create 5? A positive 5. This then gives us our two linear factors, 2x plus 5 and x plus 1, so our factorisation is 2x plus 5 multiplied by x plus 1. Here's another example. Start by multiplying 3 by negative 4, which gives us negative 12. We now need to find two numbers which multiply together to create negative 12 and which add together to create negative 1. The options are 3 and negative 4. We now use this to split the middle term. So we have 3x squared at the start, negative 4 at the end, and in the centre we have negative 4x plus 3x, which essentially are the same as negative x when combined. We then set up our multiplication grid. 3x squared has to go in this space over here, negative 4 has to go in this space over here, but negative 4x and positive 3x can go in either space. Now, looking at this column as a starting point, although we could start with either of the columns or either of the rows, a common factor of 3x squared and 3x is 3x. What do I need to fill in here so that it multiplies by 3x to create 3x squared? I have to fill in an x. What do I have to fill in here so that it multiplies by 3x to give me 3x? A positive 1. Now here, if I place a negative 4 multiplied by x gives me negative 4x, and negative 4 multiplied by positive 1 gives me negative 4. I can now read off my factors 3x minus 4 and x plus 1. A final example, solve 6x squared minus 7x minus 10 equals 0. And I start by multiplying 6 by negative 10, which is negative 60. We now need two numbers that multiply to give negative 60, but also add together to give negative 7. The only choice is negative 12 and positive 5. This then allows us to split our middle term, so 6x squared and negative 10 remain the same, but this central term of negative 7x will be rewritten as negative 12x plus 5x, or positive 5x subtract 12x, either way around. Then going to draw the grid. 6x squared is in this box here, negative 10 is in this box here, and positive 5x and negative 12x can go either way around in the remaining two boxes. Now, choosing a starting point, common factor of 6x squared and 5x, the only option is x. What do I multiply x by to create 6x squared? I multiply it by 6x. What do I multiply x by to create positive 5x? Positive 5. Now, in the last space over here, what do I multiply 6x to create negative 12x? Negative 2, and just checking, negative 2 multiplied by positive 5 gives us negative 10. So the two options work, and we have our factors. So the factorisation of the original quadratic equation is 6x plus 5, x take away 2. To then solve the equation, we take each bracket in turn, set it equal to 0, and then solve the resulting mini-equations. So 6x equals negative 5, x equals negative 5/6, or x equals 2.